Hello everyone. Let's discuss traveling salesperson problem. There is a salesman and he wants to visit some number of cities. The condition applied here is he should visit a city at only once. He should not visit the cities again and again. The main challenge of this problem is we have to minimize the total path of the whole trip. So, in our examination point of view, let's discuss a problem and solution. In the question, it is given a matrix. Through that matrix, we have to solve and find the optimum path. So, this is the given matrix. So, first, using brute force approach, the possible routes are. So, this is the process of brute force approach. Let me explain to you. From the starting node 1, if the person is standing here, he can visit to 2, 3, 4. Then after visiting 1, 2, he can visit to 3 and 4. After visiting to 3, he can visit to 2, 4. After visiting 4, he can visit 2, 3. Then he can visit 4. The remaining is 3, 4, 2, 3, 2. And finally, he should reach the initial position, starting position, which means 1. So every node, the last one is again 1. If we solve the problem using brute force approach first, then we have a clarity of solving the whole problem. So how this solve, let me tell you. So from this point to this point is our target. So now this is 4 and this is 1, right? Last step is 4 to 1. In the given matrix, 4 to 1 is 8. So let's place 8. Then 4 to next one is 3. 3 to 4. 3 to 4 is 12, including 8, because 3 to 1, because we are going backward up to 1. So we have to traverse back. For that we have to add 12, which is 3 to 4, and again 8, 4 to 1. This is 20. Then similarly 3 to 1 is 6 and 4 to 3 is 9, adding 15. So now the minimum of 20 and 15 is, as we know, it is 15. So now again 2 to 3. 2 to 3 is 9. So 9 plus, and this path is 20. Total 29. And now 2 to 4 is 10. 10 plus this path is 15. Total 25. So now we have to calculate the minimum from 2, 3, 4, 1, 2, 4, 3, 1. So the obviously the minimum is 25. Let's keep 25 here. So similarly we have to do this nodes, and finally for the last step, 1 to 2 is 10, 1 to 3 is 15, 1 to 4 is 20. So after adding this total path, we can get the minimum as 35. So the solution for this whole problem is 35. 35 is the optimum path. So this is the solution we get from using brute force approach. So the same solution we are getting by using dynamic programming approach. Okay, then why you are using brute force approach means, in our examination point of view, we can have a guarantee and we can get a clarity of getting solution as 35. Even before solving the actual solution, we can have a exact answer. So this is the formula of dynamic programming approach of traveling salesperson problem. This is the formula here we are using. So let me explain this formula. So how this formula was framed: G of 1 comma 2 3 4, which means 1, it is the initial node. From 1 to we can travel 2 3 4, either 2 or 3 or 4. We can travel to 3 different nodes. That's why these are the nodes which we can travel. This is the initial starting node. So we have to find the minimum of C1k, which means cost of the path from the first node to node 1 to remaining nodes. K means 2 3 4, the remaining nodes are 2 3 4, right? So plus g of k comma 2 3 4 minus k, which means if we in the first iteration or in the first case we take 1 and 2, then in the second one we can assume 1 3, and in the third one we can assume 1 4. So this is the process. That's why we are just eliminating 2 first, then we are eliminating 3, and finally 4. That's why we are taking minus here. From that point we derive a formula for this traveling salesperson problem. Let me explain the solution by using this formula. Now we have to find the path from each node. Because of getting this answer from initial node to 2 3 4, we are getting whole answer. For example, first of all, if we substitute this formula here, minimum of C1 to initial node and then 2 plus g of 2 and the remaining are 3 4, and 1 3 and the remaining are 2 4. So in this way we substitute this formula. For solving this we have to find out this value and then this value first. For that we have to solve these things first. So g of 2 comma 3 4, yes, minimum of 2 3 plus g of 3 and the remaining is 4, the same thing here. Next, c of 2 3, in the given matrix the cost from 2 to 3 is 9 plus, so g of 3 comma 4, this is also like this one. So we have to find a solution for this one also. So we apply again the minimum the formula here. So after applying this formula to this thing, we can get the answer as 20. So these similar things are there. So here if we observe 4 comma pi means nothing. After, let me show you, this is 4 comma 1. So 4 comma pi, up to this the things are the total nodes visiting are over. After this again it needs to visit the initial position. So that is what in formula we are showing it as pi, which means it is attending to no new city. So but it is actually visiting the city 1. So we substitute 4 comma 1 as 8 as in the previous matrix or in the diagram. So this is what we are getting after substituting the values, and this is for 2 3 4 and then 3 2 4 4 2 3. 23 is for this. So finally after substituting all this one, we can get the answer as 35. Just observe, within few minutes we obtain the solution 35 by using brute force approach. So we can have a confirmation that this 35 answer is 100% sure. So this is the complete scenario of traveling salesperson problem. Thank you.